Hello, let's continue our Sudoku adventure with Perspective Change by Palfly Kampling. So this continues our theme week for doublers, and today we have region sumlines in addition to the doublers. So let's go over those rules. We have standard 6x6 Sudoku rules, so that means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have exactly six doublers in the grid. So this is the same doubler rules as the past 2 days, but just in case you haven't encountered that yet. Every single row, every single box or column, and every single box has exactly one doubler in it. And what the doubler does is it doubles the value of the cell. So if I put a 2 in a doubled cell, I'm using green to designate a doubled cell here, then the value is actually 4. And that's the value for constraints that mention value. So in this case, it's the value that's used in the region sumline constraint. Another property of doublers is we cannot double the same number twice. Each digit gets doubled exactly twice. So we cannot do a 2 and a 2 like this because the 2 is getting doubled twice. We can do a 1 if we want. Additionally, normal Sudoku rules are not affected by doublers. We're still putting the digits 1 to 6 in every row column box. So don't worry about the doublers. Like, you're not going to be repeating the digit 2 just because one of them has a doubler on it. That's not going to happen. It's still every row column box has exactly 1 through 6 in it as digits. Okay, so we also have region sumlines. So what we do is for a region sumline, we divide it into segments based on which box it occupies. If a line re-enters a box, it makes a new segment. So like that, right? So this is one segment, this is another segment, this is a third segment. The sum of the values of the cells of each segment is the same for any given line. Between different lines, the sum can be different. But so let's just use this. I don't know. Let's find an easy example. This is an easy example. So we separate this into 2 segments. Let's assume there's no doublers involved. If this is, say, a 6, this could be 2 and 4, because 2 plus 4 is 6. If we did start involving doublers, I'm going to get rid of my coloring that I have here. Let's say this 2 was doubled. Let's say this cell was doubled. I could double a 1 to get 2, add 4 to that, that's 6. The value is the same between these. Or this could be a 3, and this could also be doubled. So this would be a valid sum line using doublers. All right, so that's it. Those are the rules. I know doublers always add a bit of extra complexity because you have to consider whether a doubler might be involved in your cases. So yeah, just be careful about that. And there's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, well, I noticed 2 things right away as I was explaining the rules. First is that this has to be a doubled value. And the reason for that is if it was not doubled, the biggest it can be is a 6, and the sum of these is at minimum 1, 2, 3, 4, which has to 10. So there's no way that's going to work. So this has to be doubled in order for it to be able to do that. So it's row column and box. The rest is not doubled. I'm going to use a light gray. I'm going to use a light gray to designate that. All right, so these sum to at least 10. So this is a 5 or a 6 doubled. We don't know which yet. If it is a 5 doubled, then this is a non-doubled 1, 2, 3, 4. Okay. So the other thing I noticed is that these 2 have to have the same sum because of the re-entry rule. And so one of them has to be doubled, and this is the only one that can be doubled. So the rest of its row, column, and box are not doubled. That helps this a lot. There were a lot more combinations before we did that. There's a doubler somewhere in one of these 2. All right, let's consider what this can be. So these are non-doubled. The minimum is 1, 2, 3, which is 6. We know that it adds to an even number. This can only be an even number. This can be 2, 4, or 6, and then this is 1, 2, or 3. Because the doubled value is always going to be even. So this has to be that value. So it needs to be the actual value, so even only. But we just said that the minimum is 6. So this has to be a 6, this has to be a 3, that's a 3, that's a 5. And we get lots of digits. Very nice. That's a cool opening. I like that, Palfly. So we get 4, 5, 6 there. The 6 is down here somewhere. These are 4, 6, I should say. We know the order. All right, that's really good. All right, so we know there's a 5 and a 6 down here. All right, these add to 10, so they have to be a non-doubled 1, 2, 3, 4. Let's start with that. So these are the 5 and the 6. The 5 can't be doubled. So the 6 is doubled somewhere down here. Can these add to 12 non-doubled? And the answer is no. Okay, so that's really cool. This cannot be the doubler. If this was the doubler, it would be a 6 because we can't double the 5. These would have to add to 12. We'd have to be 6 and 6. Like, it doesn't work. We don't have doublers down here because of this 3. So this is not doubled, and it's the 5, and this is a doubled 6, and it didn't end up on the line, so it doesn't actually, the 12 doesn't do much. All right, so I do need a 6 on this line somewhere. Just because of Sudoku, I should specify. These add to 5 and can't use the 3, so they're 1 plus 4. So let's see. Let's take a step back. What do we have here? We have a pair here, 2 and 5. This is non-doubled, and it's not a 4, 5, or 6. So this is a 3, and we need the 1 and the 2. That's very helpful. This is 4 or 5, non-doubled. Can't be the 4 because this would have to be... Ooh, can it be the 4? I was going to say this would have to be 1, 3, and it can't be because neither can be 3. We could double the 1 and put a 2. Yes, that is possible. So this could be 4. All right, let's keep that in mind. That's what I was talking about being careful about your logic. This is certainly not a 5, though. That would overwhelm this sum immediately. Can it be a 4? No, because if this was 4, it would be undoubled with an undoubled 1, but you can't put a 1 here. In fact, we know what this value is. This is a 2. So, yeah, we have to be 2 plus doubled 1 to get 4. That's the only way we're doing this. So 2 plus doubled 1 does make a 4. That's 5. Oops, not 8. That makes this a 5. These are not 5s. So we have 2 more doublers left, and we know that they are the 2 and the 4. All right. We can fill these digits, 2, 3, 6. That's not a 6. All right, the double digits are 2 and 4. Should I think about the minimum this could add to? I mean, 1, 2, 3 is the naive one, which is 6. Maybe I should fill more, do more Sudoku here. These are, we know there's a 2 and a 5 here. Ah, the 5 in this box is placed, actually. It's placed here. And we know it's not doubled. The 2 is up here. This is 2, 4, 6 in general. Down here we need a 1 and a 3. Along with the other 4, 6. Is a 6 too big? I don't think a 6 is too big. It would put a 6 here. So this would equal the sum of these two. Oh, this is a sticky ending. Maybe I'm missing something obvious. Okay, so this is either non-doubled entirely, which would put the doubled 2 here. Oh, no, sorry, these can't be doublers. Oh, that's what I'm missing. That's the obvious thing. I didn't mark the doublers here. I didn't mark this doubler here. Yeah, so there's a doubler here and a doubler here. This cannot be the doubled 4, so this has to be the doubled 2. So we have a doubled 2 with a 6. That's a 3. So we know that adds to 10. So these 3 need to add to 10. And we can use a doubled 4. In fact, 4 can't be on a non-doubled cell down in this box because there's a 4 down here. It's doubled. So that gives us a bunch of digits. Gives us the 1, the 2, the 6. Oh my goodness. Gets us these digits. Ooh. Hold on. Oh, that was intense. All right, 1, 6 here. All right, so do we need the 3 or the doubled 4? We need the 3 in order to add to 10. So the double 4 ends up not on it. We have the double 2. So we can finish coloring here, and then we can finish our digits. 2, 3, 1, 2, and 1, and there we go. All right, that was a cool puzzle, Palfly. I liked the logic that happened there. This was a neat idea. I liked that a lot. Just to force a doubler. That was neat. It's good that you had a doubler not end up on a clue. We need to avoid the assumption that... Oop, this is doubled. We need to avoid the assumption that doublers always end up on clues. That doesn't always happen in doublers, but it can still be useful to know that there was a doubled 4 here, even though it didn't end up on a clue. So very nice teaching moment there. I hope you enjoyed this. I certainly did. And if you did, then why not leave a like, subscribe, and a kind comment below.